Welcome back to One Big Question, where we explore the fascinating mysteries of nature, science, and the universe that surrounds us. Today we dive deep into the golden world of honeybees, specifically focusing on the architectural marvel hidden inside their busy hives. Have you ever stopped to wonder why the honeycomb is built with such precise, hexagonal shapes, repeating perfectly without any errors? Why do bees strictly choose the hexagon instead of circles, squares, or triangles, which might seem easier to construct at first? This is not a random accident of nature, but a calculated engineering solution that solves a complex problem of efficiency and storage. The perfection of the honeycomb has fascinated human thinkers for thousands of years, sparking curiosity in the minds of great philosophers. Even Aristotle, back in ancient Greece, marveled at the geometric elegance of the hive, recognizing its incredible efficiency and structural beauty. Centuries later, Leonardo da Vinci also studied these natural patterns, realizing that bees were utilizing a sophisticated form of natural mathematics. But to understand why the hexagon is the chosen shape, we must first understand the most precious resource within the hive. That resource is beeswax, a substance that is incredibly difficult and energy-consuming for the worker bees to produce in large quantities. For every single pound of wax produced, bees must consume and metabolize approximately 8 pounds of honey, a massive energy cost. Because wax is so expensive to make, the colony cannot afford to waste even a single gram of this building material. If bees built their cells as circles, there would be wasted gaps between them, requiring extra wax to patch the holes. These gaps would not only waste valuable wax, but also create weak points in the structure, compromising the integrity of the hive. Triangles fit together perfectly without gaps, but they have a high perimeter to area ratio, meaning they use more wax for less storage. Squares are better than triangles, but they still require more wall material to hold the same amount of honey as a hexagon. The hexagon is the geometric champion, offering the maximum internal storage space while using the absolute minimum amount of wax wall. This shape allows bees to build a lightweight yet incredibly strong honeycomb that maximizes storage capacity for their precious honey reserves. Every drop of honey is stored efficiently, ensuring that the colony has enough food to survive the long, cold winter months. When we analyze the data, the hexagon is the undisputed winner of efficiency, saving the colony vast amounts of energy and time. The third unappealing habit is trying too hard to impress by showcasing achievements, wealth, or connections to famous people. It was the Roman scholar Marcus Terentius Varro who first proposed that the hexagon is the most efficient structure for packing space. For over 2,000 years, this remained just a theory, widely accepted as true but never mathematically proven by any scientist. It was not until the modern era of computing that we finally had the tools to rigorously prove what bees know instinctively. In 1999, mathematician Thomas C. Hales finally provided the mathematical proof, confirming that the hexagon is indeed the perfect shape. Hales proved that no other shape can tile a plane with less total perimeter than the regular hexagon, confirming nature's genius. But do bees actually know geometry? Do they calculate angles and measure wall lengths with tiny tools while building their hives? The answer is likely no. Bees do not perform complex calculations. Instead, they rely on simple physical laws to guide construction. Research suggests that bees actually start by building circular tubes, shaped around their own bodies as a mold for the wax. As the bees work, their body heat raises the temperature of the wax to about 45 degrees Celsius, making it soft. At this specific temperature, the wax becomes a viscous liquid, allowing it to flow and stretch without breaking its structural integrity. Think of soap bubbles. When round bubbles are packed together, the walls between them flatten out and naturally form hexagonal intersections. Surface tension pulls the wax at the junctions of 3 circular cells, straightening the walls until they meet at perfect angles. The walls naturally settle into 120-degree angles, which is the defining geometric characteristic of a regular hexagon. Once the heat dissipates and the wax cools, the shape hardens, locking the hexagonal lattice into a permanent, sturdy structure. So the bees provide the heat and the raw material, but the laws of physics do the heavy lifting of shaping. This collaboration between biology and physics results in a structure that is not only efficient, but also incredibly strong,
just like in nature,
and durable. The hexagonal lattice distributes weight evenly across the entire comb, preventing any single point from bearing too much stress or load. A honeycomb can hold a significant amount of honey, many times its own weight, without collapsing under the heavy, sticky load. Humans have learned from this. We use honeycomb structures in airplanes, rockets, and cars to create materials that are light, yet strong. Beyond storage and strength, the hexagon also plays a crucial role in raising the next generation of the colony's workforce. The compact arrangement allows nurse bees to pack the maximum number of larvae into a small area, making care more efficient. This dense packing also helps in thermoregulation, keeping the brood warm and at a stable temperature required for healthy development. Not all bees build such perfect hives. Bumblebees, for example, build messy, pot-like structures that are far less efficient in space. Evolution likely favored honeybees that built hexagons because they wasted less energy on wax and survived harsh winters more often. Efficiency is survival. In the brutal game of nature, saving energy on construction means having more energy for foraging and defense. The hive is not just a warehouse, it is a nursery, a pantry, and a fortress, all built on a geometric foundation. From the perspective of a bee, this architecture is simply life. It is the only way they know how to build. It is a reminder that nature often finds the best solutions long before humans even begin to understand the problem. Today, biomimicry leads us to look at the hive for inspiration in designing sustainable cities and efficient storage systems for ourselves. We even see this shape in the James Webb Space Telescope, where hexagonal mirrors fold together to capture light from the universe. From the smallest insect to the largest telescope, the hexagon remains the ultimate symbol of efficiency, strength, and connection. The next time you see a bee buzzing in your garden, remember that it is a master architect of the natural world. It carries within its tiny genetic code the blueprint for one of the most mathematically perfect structures ever created on Earth. We harvest their wax and honey, often taking for granted the incredible amount of labor and engineering required to produce them. Beekeepers understand this value. They see firsthand the delicate balance of the hive and the precision of the comb every day. When the cells are full, bees cap them with a thin layer of wax, sealing their hard work in a perfect vault. The hexagon is more than just a shape.
From this
It is a
bustling
testament to the power of
honeybees
collective
embark on their
intelligence
vital
and natural
mission,
selection.
connecting the hive to the
To summarize, bees build hexagons to save expensive wax, maximize storage space, and create a structure that is incredibly strong. They achieve this through a combination of biological instinct and the laws of physics,
the soap bubble,
allowing the wax to settle naturally. It is a perfect example of how living things interact with the physical world to create solutions that are simply elegant. For the young bee emerging from its cell, the hexagon is the first thing it knows, the cradle of its existence. And for the colony facing winter, the hexagon is the granary that holds the fuel they need to see another spring. Without the efficiency of the hive, bees might not thrive as they do, and our world would look very different. Nature is filled with patterns, but few are as iconic or as functionally perfect as the honeycomb of the honeybee. We have learned so much from them, yet there are still so many mysteries hidden within the buzzing of the hive. Science continues to explore how these tiny brains
The
make
foraging
such
behavior
complex
seems
decisions,
consistent with the data from
revealing
yesterday.
new layers of complexity every single year. Perhaps the bee does not need to know math because the math is already written into the very fabric of nature. As night falls and the hive quiets down, the hexagonal walls stand firm, protecting the colony until the sun rises again. From a drop of nectar to a geometrical masterpiece, the story of the honeycomb is a story of nature's brilliance. It invites us to look closer, to ask questions, and to appreciate the intricate designs that exist right under our noses. We hope this deep dive into the world of bees has given you a new perspective on these incredible little architects. What other patterns in nature do you find fascinating? The spiral of a shell? The branching of a lightning bolt? If you enjoyed this video, please hit the like button and share it with a friend who loves science and nature. Thank you for watching One Big Question. Join us next time as we unravel another mystery of our amazing universe.